Okay, so let's get started. We're going to be taking a look at working with a pulse width modulated style nitrous control in our Motec M1 programming. Now, pulse width modulated control is going to be when we use a solid state relay to control our nitrous solenoid and control the amount of nitrous flow coming into the engine in a very specific manner. We'll find that we have a lot more flexibility in terms of the actual control and the power output utilizing nitrous when we are working with a pulse width modulated style format. We've already talked about the basic on-off style control, which works, and there's a lot of programming language found within the Motec that support it natively, but we'll find when we're doing a pulse width modulated control in this specific firmware package, so GPR or GPRP package, we'll find that we have to get a little bit creative in how we set up and program and work with this pulse width modulated control because it's not supported directly within the software as a feature for nitrous. So first things first, what we need to do here is jump in and talk about the components that we want to have installed on our vehicle in order to utilize a pulse width modulated control. Now, whether you're doing a wet or a dry shot of nitrous or a fogger or direct port, doesn't really matter. When we're controlling everything here with the Motec in this pulse width modulated control, everything is going to be the same in terms of how we configure things, except when we deal with our fueling. And we'll talk about how to do that, how to set that up with a dry versus a wet kit here a little bit later in this training module. Okay, so the very first thing we need to do is take a look at our schematic here, and this will again outline what we need to have in terms of components and how things should be wired in order to take advantage of this style control. Well, first things first, we're going to find on our schematic here, we have a nitrous bottle, we have a nitrous solenoid, we have a basic on-off toggle switch, we have a battery just to represent power and ground here on our schematic. We have a nitrous nozzle. Now this is going to be, looking at this specific example, this would be a nitrous setup with the single nozzle as a fogger and a dry setup. You could have direct port, doesn't really matter, but in this case, we're just doing a single fogger for the example. We also have the solid state relay, and that's going to be a Holley specific solid state relay, part number 15620NOS. This is a solid state relay I work with pretty frequently anytime I'm doing any type of pulse width modulated control. We do have to have that solid state relay to control our nitrous solenoid in this example. What we also find in this particular example here is going to be a pressure sensor that's not going to be utilized unless you want to monitor bottle pressure, nitrous bottle pressure in your logging, but I just have that in the schematic here. Again, it's not going to be utilized in this strategy or routine, as we found when we were doing the on-off control that's natively supported in the software. We found that we were able to integrate bottle pressure and a bottle heater in that nitrous routine. That's going to be absent from our particular control routine here. So that's going to rely on you having your bottle pressure adequate so the nitrous jet will flow what it's rated to flow. So if we have too little bottle pressure, it's not going to flow as much as the rated jet size. Let's say it's a 75 shot or 100 shot. It should equate to approximately horsepower that we're going to see out of our engine. So if your bottle pressure, let's say, is 700-800 psi, you may not see that full 100 horsepower worth of nitrous flow. If you have too much bottle pressure, that's dangerous. That could cause the bottle to explode. So we want to be within the sweet spot, about 900 to 1,000 psi in terms of bottle pressure. So what we're going to do right now, knowing what we have going on in the schematic, we're going to move into the software of where we can actually program this pulse width modulated style control and how we're going to be configuring it, everything up. We'll be referencing back to our schematic as well. So I'm going to move from my tuning page right here. We're going to go into the setup area, and under setup, we're going to move across here into all calibrate. I don't have a dedicated setup page for working with this pulse width modulated style nitrous control. We can do everything from our calibrate window here. So what we're going to do first is type in at the top aux, and that's going to filter out all of the available auxiliary outputs. In order to utilize this, we need to have an auxiliary output configure. An auxiliary output can allow us to control in either an on-off type of fashion or pulse width modulated. When we were talking about our nitrous control in the last few tutorials, those nitrous tutorials were taking a look at doing the on-off control. Pulse width modulated is not natively supported in this Motec firmware package. So this is where we need to get creative and going in and assigning a specific output to control a solid state relay and then to control the device that we're trying to pulse width modulate, which in this case would be that nitrous solenoid. So the first thing I want to do here is just use my auxiliary output 1. I'm going to assign it to an actual output for control. Now what's to note here with the Holley solid state relay, if we reference our schematic, we're going to find that we have 3 wires for control over the solid state relay. We have our number 3 input pin to the solid state relay. That's coming from a fused power source. So that's our power in. The number 1 is going to the number 1 pin position on that solid state relay. That will be the power feed going to the nitrous solenoid. And then we find that pin 2 will be what we pulse width modulate from our Motec, and that's going to be in a low side configuration. Now it's important to know whether it's a low or a high side control, because in this case, we want to be able to make sure we're assigning the correct output for control. We have a lot of options we can utilize here in our drop down. Let's see what we have available. We have half bridge outputs that can control both in a high or a low side.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.